Here we have a cylinder that's inside of a cone, and what we want to do is find the cylinder with the largest volume that can fit inside this cone. The cone has a fixed radius or a constant radius denoted by a big R, and then the cone, the height is also fixed and constant. So the height of the cylinder, we'll call it small h, and then the height of the cone, we'll call it big H. And then the radius of the cylinder be the small r, and then the radius of the base of the cone will denote it by big R. And if we look at this right triangle right here, and this is what we have. And so the triangle ABC, which is inside of triangle ADE, and these are similar triangles, and therefore the distance from here to here, which is big H minus small h, dividing by the length of this side of the bigger triangle, be h minus h dividing by h. And then this side dividing by this side, it will be r, small r, divided by big R. And once again, the reason we have this is because the two triangles are similar. The volume of the cylinder is pi r squared h, and we had this relationship from the two similar triangles. From here, multiply both sides by the big H, and we have h minus h is equal to big H times r, small r, dividing by big R. And then move this to solve for small h, and we have small h is equal to big H minus big H dividing by big R, multiplying by small r. Replacing h by this expression, and we have volume of cylinder is equal to this. Simplify, then we get pi times r squared times h minus pi times h over r times r to the third. We want to maximize the volume of the cylinder, so we'll take the derivative with respect to r. Since the volume of the cylinder now is a function of small r, so take the derivative with respect to r. Recall that the big H and the big R, they are fixed and they're constant. And so the derivative here would be pi h times 2r, so we get 2 pi h r. And then here we get pi h over r, and then the derivative of r to the third is 3r squared. And so we end up with 3 pi h over r times r squared. And now we set the derivative equal to 0. And so we get this expression equal to 0. Divide everything by pi, and we end up with this. Common factor is hr, so we get hr times 2 minus 3 over big R times small r. So we get 2 minus 3 over big R times R is equal to 0. Solving for small r, we get R, which is the radius of the cylinder, is equal to 2/3 times the radius of the cone. Earlier we had height of the cylinder is equal to height of cone minus height of cone over radius of cone times radius of cylinder. But small r is 2/3 times big R. And then simplify here, we get 1/3 times big H. So to get the cylinder with the largest volume, then we need to let the radius of the cylinder be 2/3 times the radius of the cone, and we need to let the height of the cylinder be 1/3 the height of the cone. So in the place of R here, we get 2/3 times the radius of the cone, the base of the cone. And then for the small h, we get 1/3 h. And then simplify, we get 4 over 27 times pi times radius of the cone square times the height of the cone. And so in summary, if we want a cylinder with the largest volume inside of the cone, then the volume of the cylinder will be 4 over 27 times pi times the radius of the cone squared, and then times the height of the cone. And that's the end of the video.